Okay, okay, I'm recording. So now let's make a rectangular patch antenna. First, we need to know the dimension of this antenna. Um, and to do this, we can search patch antenna size calculator and pick one. Put in our patch antenna dielet dielectric constant, which is 2.2, the 05880, and the height of the substrate will be um actually, let me check. Yeah, I just want to make sure it is correct. So we go to here, we're able to see the size would be 1.575 millimeters, right? So here we put in 1.575 millimeters. And the frequency of operation, we would choose, let's just use 2.4 gigahertz. What we get is width is 49 and length would be 41. Um, let's just follow this. Okay, width would be the length of this one, and length would be length of this one. And this one is an inserted or inset pin or feed. We will make a special feed for this one. So when we have this, first thing we need is a box like this, right? And we would give them some parameters. Um, so the position of the center would be patch X divided by 2, and then patch Y divided by 2, and it will be on the 0. And then we need to give it because this is a substrate, so we need a size, right? So another calculation would be the X would be let's say the X would be 8 centimeters. We will talk about this why this is 8 centimeters later. I am not 100% sure. And um, I would say is the half of this. So we would give 100. So it will be 100. No, 1 centimeters. This would be 5 centimeters. So 10 centimeters, right? This will be 10 centimeters. And the other one would, we could give 8.2 centimeters. Okay. And the X would be the patch X feet Y. And the Z size is the thickness, which we will define as 1.575. Yes. Fit all. So this would be the substrate. I just realized the dimension of the substrate should be um, like twice the size of the antenna in the middle. So next, we need a ground plane. The purpose of having a ground plane is we have something that we are able to push all the signal on the top side of this surface. Let me just make sure recording it correctly. Okay, yes, I am. So the ground plane will be a sheet starting from here, same size with here, and then position will be the same, which is minus patch x divided by 2 minus patch y and divide by 2. The position will be 0 because it is on the bottom. And the x will be patch x. Y would be patch y. So it is here. All right. We can give it different color. And before that, I want one thing I forgot. Here we can assign the material for it, and we will give, different color, give it a little bit more transparent. And then the bottom, we will, because it's ground plane, so it would be copper. And we give a little bit as well. Because this is a ground plane, we will assign a boundary called perfect E. We do not choose infinite ground plane because that will just means there under this ground plane there is absolutely no signal. But we wanted something here and there. So let's just do this. So when we do this, we will be able to see the perfect E here, right? So after this, what do we do? We want to define this antenna on the top of this surface, right? We will do the same, have a patch like this, and then we will define the size. Previously, this we calculate the patch X and the patch Y. So this would be because I used patch X, right? Previously I was using this, and then I was using divide by 2. Now I should use divide by 4. So it would be like this. And the height would be the thickness. Okay. Then we'll be able to see that actually, let's just do this way first. Then we can go from there. And then we need to assign a name for this called antenna. For this, we will call it ground. For this box, we'll call it the substrate. Okay, at this point, for the antenna, we will also need to assign a boundary for it because it's copper. Okay, we have this two. The third one would be a port. So the port needs to be inside this structure, inside the substrate, but perpendicular to the ground panel and also the antenna. So we will choose the grid to be XZ. Now, and it needs to be a sheet as well. Why I cannot do this? Okay. Yes. So let's figure out the position. Um, uh, actually, I did not make a me. Yeah, I need to take a look at my notes first. So the position of the feed be let's define the width of the port, which is port width, and divide by 2. Let's use minus, and then we do patch divided by 2. And then we want to add some offset because the position of this feed will influence the impedance. I'll do 0. So for port width, the width of the port, I would say we can, I actually don't know which I should choosing. Let's give it 10 millimeter first. Let's see how this go. And offset, let's do 15 millimeter. And X would be port. Z would be the thickness of the substrate. It seems like it is too far. So we want it to be closer to the antenna. That means maybe the offset is too big. Let me change the offset. So let me give it 5. Oh, it's too small. So 30. 30, maybe 35. It's kind of like here. And the port, the width of the port is probably too big as well. So we can change it to 5, like that. Let me give the offset a little bit more, maybe 40. Okay. So at this point, we will give the name to B. And then we will assign a about excitation, which is lump port, terminal lump port. We will use the ground as the reference, and we will click on OK. Now, if we come to here, we will have a feed T1. Next, we need to create a open region operating frequency 2.4 gigahertz because we calculate the length as 2.4, so we click on OK. There will be a open. Next, we will do the solution setup as auto. And 0 would be good because we know it's 2.4, so I'm going to choose 3 gigahertz, and 501 is also good. Save the fields, and we'll click on OK. Then we will do analyze all. Project, we will use it as today's day. Rectangular antenna with feed inside. Okay, it's running. Let's see what the result would be. So in the meantime, my professor told me the far field radiation setup, this should be like this, and this should be like this. I don't know why, but that's a question I need to ask. Okay. The next, first thing we want to check is the terminal portal Z parameters. And we want to see the imaginary and not this one. Maybe yeah, I should Z not. Okay. I need to ask that question too. So the Z naught for the real should be 50 and imaginary should be zeros. That's when you know your feed is defining correctly. And then you will check the S parameters. We can see this is a dual band and have a 2 resonance. One at roughly 2.3 and one at 2.7. Yep. Thank you for watching.